Welcome PyCoders to the core Python tutorials for the beginners. So in the last tutorial, we have talked about some operators, their types. We have talked about some arithmetic operators. We have talked about assignment operator. We have talked about logical relational operator. So the bitwise operator is kept at the last video. The reason because the bitwise operator is too much of vast and I need to create the separate video on the same. So in this tutorial we will talk about some bitwise operator. The bitwise operator that we will have is AND, OR, XOR, then left shift and right shift, it seems. Right, so let's talk about sorry, I guess one is remaining at here, and one is complement, then OR we will have, then XOR and left shift and right shift operator that we will have. So let's talk about some complement operator. For the complement operator, okay, for the complement operator we will have the symbol which is called as a tilde. What is this symbol called? The symbol is tilde, and where it is placed in keyboard, it is placed in keyboard below of the escape keyword. Okay, so if you do below of the escape key, you can get the shift tilde symbol by the shift, it seems. Okay, so for the AND we will have the symbol of ampersand. All right, for the OR we will have the symbol of pipe. I just written in caps, symbol of pipe like this. For the XOR we will have the symbol of exponent, and for the left shift we will have the symbol of this, and for the right shift we will have the symbol of this. Right, so let's get started. First I just getting executes by the Python IDL, and then we will have the explanation on the same. So if I'm talking about exponent, if I need to calculate the exponent of 12, let's see the answer, is it working or not. Okay, so the exponent of 12 is minus 13. So how it is comes, so let's get back to the calculation. I'm just at my calculation here. For a complement I need to convert a number into the binary. If I am talking about bitwise operator, every number, every single integer is got to be converted into the binary, and then we have to get it reverse of that binary. Means I need to convert the 0 into 1 and 1 into 0, and then we have to generate the 2's complement, and again reverse the same, then we will got our complement operation. Okay, if I'm talking about the bitwise and, the bitwise and will be like, suppose print 12 and 30. So what the output it will came, if I'm click on enter, we will get the output as a 12. Right, so I'm not understanding, let's get back to the calculation. If I'm talking about an AND operator, okay, so the AND will be executing like this. This is an AND operation. Okay, convert a number into the binary. So I will got convert that number that I will have as a 12 and 13. First we will convert that number into the binary. So the 12 binary format is 1101, and the 12 13 is 1101. Right, and then we have to apply our AND operation. Inside an AND we will have the operation likewise. If there is a 1 will be there, then we have to set it as a 1. If there is 0, and we have to set it to the 0. So by the calculation I can get an output, and which is the binary I need to convert into the integer value. So output we can get as a 12. And likewise the same, or will be executes 12 or 13. So it will says an output like this, 13. Yeah, the output came as a 13. Let's take back to their explanation again. For the OR operation, again I need to convert a number into the binary and apply the OR operation, and we know the OR operation, if that both ones are equal, both one are 1, then we have to set it to the 1. If both one are 0, then we have to set to the 0, and if both among of them is 1, then we have to set it to the 1, and the output is came as a 13 behalf of the OR operation. And the XOR will be executes like this, print 12 exponent 13. And we know the XOR table, XOR comes as a 1. We know the XOR table, XOR throw the 1 if both are equal, and if both are unequal it throws the 0. So at sorry, I'm talking it reversely. If both are equal, then it throws as a 0, and both are not equal, then at the same point it throws as a 1. So 0 0 forms as a 0, then 0 0 forms as a 0, 0 0 forms as a 0, 0 0 again forms as 0, 1 1 forms as 0, again 1 1 forms as 0, then 0 0 forms as 0, and 1 0 forms as 1. So the output came as a 1. In the left shift operator, if I'm talking about left shift operator, print, suppose a part of example that we will have it here, 5, okay, 5 left shift operator 2, the output comes as a 20. Okay, first it will convert the 5 into the binary format, which is 1 not 1. Then apply the right shift, means what? It will convert the left binary numbers in by their zeros. So 0 0 1, it will be like the same. So that how we can get our output like this. So right shift, sorry, in left shift operator, it will write the zeros at the append of the binary and it will call our output. And again at the right shift, if I'm talking about right shift, print 5 2, it will say an output 1, because once we got an binary 101, then it will convert that first 2 digits as a 0 and it will forms as a 1. So all these all about the bitwise operator, exponent, then and, or, then we will have XOR, and then we will have right shift and left shift. So I guess you will get all the concept about the bitwise operator. If you like this video, please give us a thumbs up. Do like, do share these videos to your colleagues that they needs that programming concepts anymore, and keep watching this video. Thanks for watching. Happy coding.